Welcome back to Applied AI Engineer. Last episode we gave Atlas a loop, reason, act, observe, but it had only one toy tool to act with. Today we hand it a real tool belt, a calculator that does genuine arithmetic, a SQL tool that queries a live database, and our Atlas document retriever from the RAG episodes, now wired in as a tool the agent can call on demand. We'll define each tool's schema, validate every argument before anything runs, recover gracefully when a tool errors, and let the model route between them. By the end you'll have a multi-tool agent that picks the right tool for each step of a real, multi-step task. Quick orientation. Episode 9 built the agent loop. The model reasons about what to do, takes an action, observes the result, and goes around again. But a loop with one tool can only do one kind of thing. The leap to a genuinely useful agent is the tool belt, several real capabilities the model can choose among. So today is about tools, how to define them, how to let the model pick, how to validate what it asks for, and how to survive when a tool fails. Our deliverable is an agent that strings several tools together to answer a question no single tool could. Before any code, let's be precise about what a tool actually is. It's a plain function that does one concrete thing the model can't reliably do on its own: exact arithmetic, a database lookup, a document search. Each tool carries a schema describing its arguments and their types, and a one-line description that tells the model when this tool is the right choice. The model never runs the function, it only decides to call it and supplies the arguments. We run it, for real, and hand the result back as text. Keep that division clear and the whole design falls into place. Here's the shape of Atlas's tool belt. At the center is a registry, a simple map from a tool name to its callable and its argument schema. Hanging off it are three real tools. A calculator that evaluates arithmetic safely. A SQL tool that runs read-only queries against a local database. And search docs are Atlas retriever from episodes 5 through 7, reused verbatim, now exposed as a tool the agent can invoke. The registry is the single source of truth. To add a fourth tool later, you add one entry here and nothing else changes. Let's build the three tools, one at a time, and run each so you can see it genuinely work. The theme throughout is safety. Every tool does something powerful, so every tool needs a guardrail. We'll start with the simplest, a calculator, and the guardrail there teaches a pattern we reuse for the rest. The calculator's argument schema is a pedantic model with one field, expression. Notice two things. The docstring on the class is the tool's description, the sentence the model reads to decide when to use it. And the field description spells out exactly what kind of string we expect. We never let the model's arithmetic float through as a guess, we evaluate it ourselves. The dictionary of operators above is the allow list for that evaluation, which the next slide uses. Here is the safe evaluator. We parse the expression into a syntax tree, then walk it ourselves, permitting only numeric constants and the operators in our allow list. Anything else, a function call, an attribute access, an import hits the final raise and is refused. This matters enormously. A naive tool would just call Python's eval, which would happily run whatever the model produced, including malicious code. A tool is an attack surface. Treat every argument as untrusted input, because in an agent it effectively is. Run it and the calculator returns 17,760, a real computation, not the model's best guess at multiplication. This is the whole reason a calculator tool exists. language models are notoriously shaky at arithmetic, so we hand the numbers to Python and get an exact answer every time. The agent stays in charge of deciding what to compute. The tool guarantees the computation is correct. The SQL tool is more dangerous, so its schema does more work. A pydantic field validator runs on the query before the tool ever sees it. It strips the statement, rejects anything with a second semicolon, and refuses anything that isn't a select. That means the model can read the books all it likes, but it can never drop a table, delete a row, or chain a sneaky second command. This is argument validation as a security boundary the model proposes, but the schema decides what's even allowed to run. The function itself is tiny, and that's the point. By the time execution reaches it, the validator has already guaranteed the query is a single, safe select. We open the local SQLite database, run the query, close the connection, and return the rows as a string the agent can read. A small setup script seeds this database with a seeds table, one row per customer workspace, so the agent has genuine numbers to query. All the caution lives in the schema, the tool stays clean. We seed the database, then ask it for the total active seats across all workspaces. Back comes 296, a real aggregate computed by SQLite, not invented by the model. This is the second superpower of tools. They connect the agent to ground truth. The model doesn't know your numbers, but it knows how to ask for them, and the SQL tool fetches the real answer from the real table. Here's a payoff from the whole RAG arc. This is the same local embedding model and the same cosine similarity search we built back in episodes 5 through 7. Embed the question, compare it against the pre-embedded docs, return the closest passage. The only new thing is the wrapper, a schema with a question field, so the agent can call retrieval as a tool whenever a query is about the product. Your RAG pipeline doesn't get thrown away when you build an agent, it becomes one of the agent's tools. Ask it how to reset a password, and the retriever returns the exact passage from the atlas docs. Semantic search, not keyword matching, so the wording doesn't have to line up. The crucial shift from the RAG episodes is who's in control. Before, we always called retrieval. Now the agent decides whether a step even needs the docs, and only then reaches for this tool. Retrieval has gone from a fixed pipeline stage to an on-demand capability. We have 3 tools, each guarded by its own schema. Now we need one place that ties them together, takes the model's chosen tool name and raw arguments, validates them, runs the tool, and turns any failure into something the agent can recover from. That single choke point is called dispatch, and it's where reliability lies. Picture the path of a single tool call. The model emits a tool name and some raw arguments. Those flow into dispatch, which first validates the arguments against that tool's schema. If they're malformed, it returns an error string instead of running anything. If they pass, the tool runs for real, and even then, if the tool itself throws, we catch it and again return an error string. Either way, an observation comes back to the loop. The key property, a bad call never crashes the agent. It becomes feedback the model can read and correct on its next step. Here's the registry in full. It maps each tool name to a pair, the function to run, and the pydantic schema that validates its arguments. That's the entire tool belt expressed in one small dictionary. Routing reads from it, validation reads from it, and adding a new tool means adding one line here. This little structure is what keeps a growing agent from turning into a tangle of if statements. Dispatch is the gateway every call passes through, and it handles 3 distinct failure modes. If the model names a tool that doesn't exist, we say so and list the real ones. If the arguments fail schema validation, we return the validation message. And if the tool itself raises at runtime, we catch that too. Notice every branch returns a plain string, never an exception. That design choice is what makes the agent resilient. The model always gets a readable answer, even when the answer is that didn't work. Here's why. Here's dispatch exercised against all 3 tools plus 2 deliberate attacks. The first 3 calls run for real and return their results. Then we feed the calculator an import expression, refused by the asked worker. And we feed the SQL tool a drop table, refused by the validator before it ever touches the database. Both attacks come back as calm error strings, not crashes. This is what validate, then run buys you. The agent can misfire all day and the system just keeps going. Tools and dispatch are the machinery. Now the brain on each step. The model looks at the task and the work so far and decides which single tool to call next or whether it's done. We drive that decision through the authenticated Claude command line tool, asking for one JSO object per step. Let's wire the loop. The model can only choose a tool it knows about, so we generate the menu straight from the registry. For each tool we pull its JSO schema, list its argument names and types, and tack on the description from the docstring. There's no handwritten list to keep in sync. The menu is derived from the same schemas that do validation. Define a tool once, and both the model's view of it and the guard rail around it stay in lockstep. The system prompt is a contract. We tell the model, every turn, emit exactly one JSO object, either a tool call with a name and arguments, or a final answer. We give it a one-line hint about when each tool fits, plus the schema description of the seats table so it can write sensible SQL. Constraining the output to a single JSO object is what makes the loop parsable. We are not hoping the model behaves, we are giving it a narrow, machine-readable shape to fill in. This is where the real model makes the real decision. We hand the system contract plus the transcript so far to the authenticated Claude command line tool, feeding the prompt on standard input to dodge any shell quoting trouble. It replies with our JSO object. We slice from the first brace to the last and parse it. No API key is needed here, the CLI is already authenticated. The model chooses the tool, our code does everything else deterministically. And here's the loop itself, the episode 9 pattern, now choosing among 3 tools. Each step we ask the model for a decision. If it's a final answer, we're done. Otherwise we dispatch the chosen tool, validating and running it for real, then append the observation to the transcript so the next decision is better informed. Notice the hard cap of 6 steps. An agent that can loop must never loop forever, so a step budget is non-negotiable. We'll harden this further with memory and checkpoints in episode 12. Here's a single step drawn out. The task and the transcript so far go to Claude, which reads the tool schemas and emits one JSO decision. That decision routes to exactly one of the 3 tools, calculator, SQL, or search. Routing, in the end, is just the model choosing a name from a menu. Everything downstream of that choice is plain, deterministic Python. The intelligence is in the pick. The reliability is in the machinery around it. Now the moment everything has been building toward. We give the agent a question that no single tool can answer. It needs the docs, the database, and the calculator, in that order, and we watch it route between them on its own. This is a real run against the real model and the real tools. Watch the routing. Step 1. The agent doesn't know Atlas's billing policy, so it calls search docs and learns billing is per active seat. Step 2. It needs Acme's active seat count, so it writes a real SQL query and gets back 90. Step 3. It multiplies 90 by 12 with the calculator and gets 1080. Step 4. It stops and reports the answer. 3 different tools, chosen one at a time, each observation feeding the next decision. That chaining, picking the right tool for each step, is exactly what separates an agent from a single chain. Here's that run as a picture. Search docs establishes the policy, the SQL tool fetches Acme's 90 active seats, the calculator turns 90 times 12 into 1080, and the model assembles the final answer. The arrows are the important part. Each tool's output becomes context for the next decision. No human wrote this sequence, the model discovered it, step by step, by reasoning over what it still needed. That's the whole promise of tool using agents made concrete. Real runs aren't always clean, so recovery has to be built in. Here the model's first query has a typo, form instead of from. Because dispatch catches the database error and returns it as a string, the agent simply reads the message and tries again with a corrected query. Errors aren't dead ends, they're observations. An agent that can read its own failures and adjust is far more robust than one that crashes on the first mistake, and you got this for free from the dispatch design. The first attempt comes back as a clear syntax error, near form, not a stack trace, just a sentence. The corrected second attempt runs and returns umbrella with 140 active seats, the busiest workspace. This is the recovery loop in miniature: fail, observe, fix, succeed. In production, you'd let the agent take a couple of self-correcting passes like this before giving up, and we'll formalize that resilience when we get to guardrails in episode 14. A note on the wider ecosystem: since we drove tool choice through the CLI today to keep it transparent, the native APIs make this even cleaner. Claude returns structured tool use blocks with the arguments already passed, and OpenAI does the same under the name function calling, so in production you skip the hand-rolled JSON slicing entirely. Frameworks like LangChain and LangGraph go further, turning a decorated Python function into a tool whose schema is generated automatically. The mental model never changes, though. A tool is a name, a schema, a description, and your code that actually runs. Step back and look at what you assembled. 3 real tools, each with a guardrail matched to its danger. A registry and a dispatch layer that validate every argument before a single line of tool code runs. Error handling that turns failures into observations the agent can recover from. And a loop that lets the real model route among the tools to solve a multi-step problem end to end. This is a genuine tool using agent, small, but real in every part. Let's recap. A tool is just a function plus a schema plus a description. The model decides which to call and with what arguments, and your code runs it safely. You validate every argument at the door, because in an agent the model's output is untested input. And your dispatch layer turns every failure into a readable observation, so the agent recovers instead of crashing. Next episode we go from one agent with tools to many agents working together, planner and worker patterns, supervisors, and human-in-the-loop interrupts, multi-agent and orchestration. See you there.